Here's a rewritten version, same story, new wording, no timestamps or headers. The signal now arriving on Earth left Voyager 1 almost a full day earlier. For nearly 23 hours it traveled alone through the dark, crossing more than 24 billion kilometers of empty space before finally reaching the dishes of NASA's Deep Space Network. And what it carried this time is something scientists still can't fully explain. Voyager 1 isn't a modern spacecraft. It has none of today's computing power, no artificial intelligence, no advanced propulsion. It's a small machine built in the 1970s, running on a fading power source, using technology older than almost anyone watching a video about it. It was designed to last 5 years. It has lasted nearly 50. And now, from a region beyond the edge of the solar system that no human eye has ever seen and no other spacecraft has ever measured this way, Voyager 1 is picking up something strange, a faint, persistent hum drifting through interstellar space. This isn't a burst or a glitch, not a single corrupted reading to shrug off. It's a continuous signal, present for years, coming from the thin plasma that fills the space between stars. And that's only part of the story, because Voyager 1 also found a fiercely energetic boundary at the edge of our solar system, in a place scientists expected a much gentler transition. It survived a failure caused by a single degraded memory chip that nearly ended the most significant mission of its kind. And before long, this machine will fall silent for good. When it does, we may lose our only instrument sitting inside interstellar space. So the real question isn't just what Voyager 1 found, it's whether we're paying attention before that signal disappears for good. Voyager 1 left Florida on September 5, 1977. Its mission sounded ambitious at the time, but compared with what it eventually became, it was almost modest. Fly past Jupiter, fly past Saturn, gather data, send back images, and then fade into history. That was the plan. A few years of planetary exploration, a scientific postcard from the outer solar system. Instead, it kept going. In 1979 it reached Jupiter and revealed a world of storms, radiation belts, and moons far more complex than anyone had expected. In 1980 it swept past Saturn, sending back data on the ringed planet and its unusual family of moons. Each flyby worked like a gravitational slingshot. Jupiter accelerated it, Saturn pushed it further outward, and after that, Voyager 1 was no longer just a planetary probe. It had become humanity's first messenger heading toward interstellar space. For decades it moved steadily outward, past the planets, past the region dominated by the Sun's influence. Then in 2012, it crossed the heliopause, the true edge of the solar system, not where the planets end, but where the solar wind loses its grip and interstellar space begins. Beyond that line, the spacecraft entered a region filled with ancient plasma, particles from stars that lived and died long before our sun ever formed. Voyager 1 wasn't just far away anymore, it was inside a medium no human civilization had ever touched directly. And from there, it kept transmitting. But the message wasn't simple, because the data didn't match the quiet, uniform picture scientists had expected. Interstellar space was supposed to be thin, cold, and largely uniform. Instead, Voyager 1 found something more active and more structured, and that discovery began with a sound. Since 2017, its plasma wave instrument has been picking up a faint, narrow, persistent hum out there. Not a dramatic explosion, not a shockwave from some solar event, not a random spike, a steady signal, present year after year, like a low vibration running through the plasma between stars. That mattered, because researchers had expected interstellar space to be calmer than this. Smoother, less variable. A place where density shifts would be hard to detect without a major event passing through. What Voyager 1 found instead was a medium with real structure, density fluctuations, turbulence, change over distance, and it's measuring all of it from the inside, in real time, in a way no other spacecraft ever has. That's what makes the hum so valuable. It lets scientists track the density of interstellar plasma continuously, rather than waiting for rare solar eruptions to disturb the medium and produce a detectable signal. It's like listening to a faint background vibration of the galaxy itself. Proof that the space between stars isn't the smooth void once imagined, but something restless. Scientists still don't fully agree on what's producing it. It might come from natural plasma oscillations interacting with the surrounding environment, or from the random motion of electrons revealing the medium's true density. Both explanations are plausible, but neither changes the bigger point. Voyager 1 detected something persistent in interstellar space that nobody expected to see in this form. And because only one spacecraft is out there to measure it, every reading matters. The hum wasn't the only surprise at the edge of the solar system. Before Voyager 1 fully crossed into interstellar space, it passed through something even more intense, a boundary researchers would later describe, almost implausibly, as a wall of fire. For decades, scientists pictured the outer edge of the solar system as a gradual transition zone, where the solar wind would slowly weaken and the interstellar medium would slowly take over.